So we look at the past paper question. Work example, the function f and g are defined as this. So the question asks us to find the f g x 8. So first we find g8. So g8 is square root of 8 plus 1. Then that is square root of 9, that is 3. And then we have the fgx, then that is the f3. Then it is 2 times 3 over 3 plus 1. So we have the 6 over 4. So it is 3 over 2. Or we can say that it is 1.5 lah, or 1.5 lah. Okay. B. Find an expression for f2. Get your answer in the form of ax over bx plus c. So a, b, c are integer to be found. So we want to find the f2x. Oh, so this is little bit complicated if your basic is not strong enough. Okay, so we have the f2x, that is the fx. So we sub fx inside the fx. So x plus 1. So it will become 2. 2x over x plus 1 over 2x over x plus 1 plus 1. Okay, so we are actually have the this one. Okay, we substitute into 2x and the x here. So 2x and the x here. So we sub here this. Then it will become something like this. So to simplify this one, okay, uh, there is a few method, but the easiest method that I use is we multiply with the denominator, LCM of the denominator. So the denominator is x plus 1. So we multiply with the x plus 1. Okay, then this one will become 2 times 2x over 2x plus x plus 1. Okay, why do this happen is because when we have this one multiply with this, then this is cancelled with this. Okay, and then we have this multiply with this. So the 2x over, we have the 2x over x plus 1 multiply with the x plus 1. Okay, then we can cancel out. Then we have the 2x here. 1 multiplied with x plus 1, then it will become x plus 1. So the final solution will be the 4x over 3x plus 1. So the 3x plus 1 cannot become 0 because the denominator part cannot become 0. Let's say we have the 4 over 0, then it's max error. Okay, so when we have a function, the denominator part have x, then we will set that the denominator part cannot become 0. So the x cannot be negative 1 over 3. So next, find an expression of G inverse and stating its domain and range. Okay, so first we must know what is Gx. Then only we can find G inverse. Okay, this one C, we have this. Okay, so we know that domain for G is actually the x greater than negative 1. Okay, so the graph for G is something like this. So the range for G is actually the y greater than or equal to 0. Okay, so we want to find G inverse. So let gy equal to x, then G inverse x equal to y. Then we have the square root y plus 1 equal to x. Then the y plus 1 equal to x squared. Then y equal to x squared minus 1. Okay, so the G inverse of x will become x squared minus 1. Okay, we need to know that the domain for G inverse Okay, so the domain of G inverse is equal to the range for the G. Okay, so range for the G is greater than or equal to 0. So the X is greater than or equal to 0. And then the range for G inverse is equal to domain of G. So domain of G is greater than or equal to greater than -1. Wait, just now this one don't have equal. So we don't have an equal here. So this is greater than, okay, greater than. Okay, so for this one, then the fx or gx, the g inverse x are y lah. Y is greater than -1. Okay, so we know that actually the f and f inverse function and their inverse is actually the graph that they reflected in the y equal to x axis. So it will something look like this. So the domain for G is actually the range of G inverse. The range of G is equal to the domain of the G inverse. Okay, so this is the answer. So we look at the graph. Okay, so we have the square root of x plus 1. So the graph is look like this. And then we have the y equal to the x square minus 1. Okay, but we have to limit the domain. The domain is the x greater than 0. Then we have the y equal to x. So the graph is look like what I draw just now lah. Okay, so we have the 0 undefined. Actually it's -1 lah. And then this one -1 0. Then this is 0 -1. 0 1, then 1 0. Okay. So they intersect at the point at y equal to x. Okay. So this is how the graph look like.